Okay. The next question that we got on the menu. Expansion of polynomials. Expand x minus 5 multiplied by actually I'm gonna write this a little bit lower just because I want to have some space on top to draw some stuff. Okay, cool. X minus 5 x plus 2. We gotta expand these brackets out. Okay, now when you're expanding, this is the strategy that you typically want to use. So we're going to multiply like the first and there, and then we're also going to multiply the first and the second. And then in blue, we can take care of the second times that, the second of the first times the first of the second, times those. Okay, and these are going to be multiplications that we're doing. Okay, so let's do the first two red terms. So we got x squared. The signs are very important. So you see how x here is positive and that x is positive, so it's going to be positive x times positive x. Okay, that's this first arrow here. Actually, I'll do these all different colors. So maybe green for this one. Plus, we have 2 times x, or x times 2. It's just more of the convention to have the number in front. That's called the coefficient. But we have x times positive 2, so that's plus 2x. Okay, then we can move on to our first blueberry line. We got negative 5 times x. Now, that negative, extremely important. You forget that negative, you're in trouble. Okay, so we got negative 5 times x, negative 5x. And the last one, I'll just draw another color on top of that. Maybe we got purple. Negative 5 times 2. Don't forget the negative, you'll be in trouble. Negative 5 times 2, what's that? Negative 10. Negative 10. Okay. Nice different colors to show where all of this comes from. All of those are multiplications because like these brackets side by side means multiplication. It may be the case that up to this point you've only seen multiplication like with an actual x, like the x for multiplication, but since we use x as a variable, we're going to try to move away from using x's to show multiplication. We're going to just like put things beside each other to show multiplication, just because x is a variable name, and it will get confusing if we have like, you know, x times x. Is that x to the power of 3 or x to the power of 2? It gets confusing. So we're gonna, in math, we're gonna start to get away from using x to represent multiplication. Instead, you do something like that. So variables beside each other, that's just multiplication. Awesome. So now that we have this, we can collect like terms. And like terms means that they have the same x attached to them. So we only got one x squared. Only x squared term. Here we got, these are x terms. And these are just, well, I guess in this case we only got regular numbers. So let's combine our like terms. In this case, our x terms are the only things that have more than one term. So that's just going to be x squared 2x minus 5x. How many x's is that in total? We got 2, but we're taking away 5. That's negative 3 x's in total. So negative 3x. And the regular numbers, well, that stays the same. There's only one regular number, and we're going to keep it that way. So we got negative 10. Cool. So that is our expanded version of the equation. And then we can have a celebration that we found it and that things are all looking good. Okay. Now their distribution is pretty much the same thing. It's just they drew it out differently. I prefer to have it this way. If you draw different colored like bars to show the multiplication, that can be a helpful tool. But eventually you'll get so good at this that you can just look at it and instantly come to the expanded version. It takes practice, but you'll get there eventually. I bet if you like math. So here, the above solution is good. Awesome. Super duper cool.